Chapter 1. The Silence Between Stars. There is a kind of silence in space that does not exist anywhere on Earth. It is not the silence of an empty room or a quiet night. It is a silence so deep and so complete that it feels almost physical, as if it has weight. When we imagine space, we often imagine stars, glowing clouds of gas, and distant galaxies. But what fills most of the universe is not light. It is darkness. Vast distances of near-nothingness stretch between every star and every world, creating an ocean of emptiness that no human has ever crossed. For most of human history, the night sky felt close. The stars looked like small lights placed just above our heads. Ancient civilizations built stories around them, believing the heavens were a ceiling, a divine painting meant to guide or watch over humanity. The universe felt personal, almost intimate. But as science advanced and humans learned to look deeper into space, that comforting illusion slowly collapsed. The sky was not a ceiling. It was an opening into something unimaginably large. When the first spacecraft left Earth's atmosphere and looked back at our planet, they revealed a truth that words struggle to carry. Earth is not surrounded by anything that protects it. There is no wall, no boundary, no gentle edge to space. There is only a thin layer of air, and beyond it, a cold, endless darkness. In that moment, humanity saw itself not as the center of a grand design, but as a small presence drifting inside a universe that does not notice it. The distance between stars is so vast that even light, the fastest thing we know, takes years, centuries, and sometimes millions of years to travel from one place to another. The nearest star system to Earth is so far away that if you could travel faster than any spacecraft ever built, it would still take tens of thousands of years to reach it using today's technology. The universe is not built for easy connection. It is built on separation. Every star is an island, every planet a lonely shore in a cosmic ocean. This raises a question that feels simple, but carries enormous weight. If the universe is so vast, and if there are so many planets that could possibly support life, why does space feel so silent? We have been listening for decades. We have pointed antennas toward the sky, searching for patterns in radio waves, hoping to catch even the smallest sign that something else is out there. We have sent messages into space, small digital bottles thrown into an infinite sea. So far, nothing has answered us in a way we can clearly understand. The silence of space does not mean that nothing exists beyond Earth. It means that whatever exists is distant, quiet, or hidden. In nature, silence is rarely empty. The deepest parts of Earth's oceans were once thought to be lifeless because they were dark and unreachable. When humans finally explored them, they found strange creatures, glowing organisms, and ecosystems that survive without sunlight. The universe may be similar. What we do not see is not necessarily nothing. It may simply be beyond our reach. Yet the silence still unsettles us. Humans are social beings. We expect responses. When we speak, we wait for an answer. When we look into the darkness of space and find no reply, it creates a strange emotional tension. It forces us to face the possibility that the universe is not built to communicate with us. It exists on scales of time and distance that make human communication almost meaningless. There is another possibility that is even more disturbing. The universe may not be silent because life is rare, but because survival is fragile. Civilizations may rise, develop technology, look to the stars, and then disappear long before their signals can ever reach another world. Time in the universe moves slowly for stars and galaxies, but for intelligent life, it may be painfully short. A single cosmic event, a shift in climate, or a technological mistake could erase a civilization before it ever becomes visible to the rest of the cosmos. This idea changes how we see our own place in the universe. We often imagine humanity as explorers standing at the beginning of a great cosmic journey. But what if we are not early explorers, but late survivors? What if countless other worlds have already lived through their moment of curiosity and then faded into silence? The universe does not preserve memories. It does not keep records of who existed before. It only moves forward, indifferent to what is lost along the way. The silence between stars is not just an empty space. It is a reminder of scale. It shows us how small we are compared to the structures that shape the cosmos. Galaxies collide and merge over billions of years. Stars are born, burn brightly, and die in explosions that release more energy than our planet could ever produce. Black holes grow silently, bending space and time around them. Against these forces, human history is a brief moment, barely visible in the vast timeline of the universe. And yet, despite this, we look up. We search. We wonder. The silence has not stopped us from asking questions. In fact, it has done the opposite. It has made the questions more urgent. Are we alone? Is life common but hidden? Or are we witnessing the quiet aftermath of countless civilizations that once looked up at their own skies and asked the same questions we ask today? The silence between stars is not comforting, but it is honest. It does not promise meaning. It does not promise companionship. It only offers reality in its rawest form, a universe that is vast, ancient, and largely indifferent to the small lives that appear within it. And yet, in that silence, humanity continues to speak, to send signals, to explore, and to imagine. The silence has not ended our story. It has only made the story more uncertain. In this silence, we begin to understand something profound. The universe does not revolve around us, but our awareness of the universe is something rare and fragile. We may be small, but we are conscious of the darkness around us. We are one of the few known forms of matter that can look into the void and ask what it means. The silence between stars does not answer us, but it frames the most important question of all. In a universe that does not speak, what will humanity choose to become? Chapter 2: Signals from the Unknown. For most of human history, the universe spoke to us only in silence. The stars burned in distant cold, the planets wandered across the night sky, and the vast black ocean between them seemed empty, mute, indifferent. Then, in the last heartbeat of cosmic time, we learned to listen. We built instruments sensitive enough to feel the faintest tremors in the fabric of space, machines that could catch whispers carried across millions and billions of years. With them, the universe began to reveal a different story, not one of silence, but of signals. Fleeting, fragile messages that crossed the dark, hinting that the cosmos is not a void, but a restless, dynamic place, alive with hidden conversations. Every signal from space is a traveler, light that left a star before Earth had cities, radio waves that began their journey when dinosaurs still walked the planet, ghostly particles born in the hearts of exploding suns. Even ripples in space and time itself, echoes of ancient collisions between objects so massive that they bend reality. These messengers arrive at Earth exhausted, stretched thin by the expansion of the universe, their stories faded but not erased. When they touch our instruments, they become knowledge. When they touch our imagination, they become meaning. They remind us that the present moment is woven from countless pasts, layered upon one another in an endless cosmic memory. In the early 20th century, we learned that the universe was not only visible but audible in a strange new way. Radio astronomy opened a hidden sky. The quiet black between stars suddenly crackled with energy. Pulsars blinked like distant lighthouses, spinning neutron stars sending out precise radio beacons across the galaxy. The Milky Way revealed itself as a vast transmitter filled with clouds of hydrogen murmuring at specific frequencies, mapping the spiral arms we could not see with our eyes. What once appeared as empty darkness became a crowded landscape of signals, each one a clue to invisible structures and violent processes unfolding far beyond human reach. Some signals arrived with terrifying power. Gamma ray bursts flared briefly and then vanished, releasing in seconds as much energy as the sun will emit over its entire lifetime. For decades, they were mysteries without origin, random flashes that seemed to erupt from nowhere. Only later did we understand that many of them were the final screams of massive stars collapsing into black holes, or the catastrophic mergers of neutron stars. These signals were death announcements written in light, marking the end of stellar lives. Yet in their violence, They also created the elements that make life possible. Gold, platinum, and many of the heavy atoms in our bodies were forged in these cosmic catastrophes. The universe kills stars to build worlds. Then there are the particles that barely interact with anything at all. Neutrinos pass through planets as if they were made of smoke. Trillions of them stream through your body every second, born in nuclear reactions inside the sun, in the cores of distant galaxies, in the aftermath of colossal explosions. They carry information from places light cannot escape. From the dense heart of a supernova, from the edge of a black hole's grasp. To detect them, we built enormous underground observatories, filling caverns with clear water or ice, waiting for the rare moment when a neutrino collides within and leaves a faint trace. These detections are like catching a single drop from a cosmic rainstorm. Yet even a few drops are enough to confirm that the universe is constantly communicating, even in ways almost impossible to perceive. Not all signals are ancient. Some are ongoing, rhythmic, persistent. The sun hums with vibrations that reveal its inner structure, like a bell whose tone tells us about its shape and density. Jupiter's magnetic field sings in radio frequencies, its massive storms shaping electromagnetic music across space. Even Earth itself sends signals outward, a growing shell of radio noise expanding at the speed of light, carrying fragments of human culture into the dark. Every broadcast, every radar pulse, every satellite transmission becomes a tiny declaration of our existence, radiating into a universe that may or may not be listening. And that question haunts us. Are we alone in the cosmic conversation, or are there other minds sending their own signals into the void? For decades, we have searched for patterns in the noise. The search for extraterrestrial intelligence listens for narrowband radio transmissions that might betray the presence of technology. We scan millions of stars, hoping to find a signal that cannot be explained by natural processes. So far, the universe has offered only ambiguity. Strange bursts appear and disappear. Fast radio bursts flash across the sky, milliseconds long, some repeating, others never returning. Their origins are partially understood, likely linked to magnetars, the most extreme magnetic objects known. Yet for a moment, when such a burst is first detected, it carries the thrill of possibility. A reminder that the line between the natural and the artificial is not always easy to draw when our knowledge is still incomplete. Even the silence itself has meaning. In the vastness of the Milky Way, with hundreds of billions of stars and potentially countless habitable worlds, the absence of clear, undeniable signals from other civilizations forces us to confront uncomfortable questions. Perhaps intelligent life is rare. Perhaps it is fragile, extinguishing itself before it can speak across the stars. Perhaps it is abundant but quiet, choosing not to broadcast its presence into a universe that can be hostile and unforgiving. Or perhaps we are simply listening in the wrong way, with instruments and assumptions shaped by our own narrow experience of what intelligence should look like. Signals from the unknown are not limited to distant galaxies. Sometimes they emerge from the very fabric of reality. When gravitational waves were first detected, humanity gained a new sense. For the first time, we could feel the universe, not just see it. Two black holes, locked in a death spiral, collided over 1 billion light-years away. The energy of their merger shook space itself, sending ripples that passed through Earth, stretching and compressing our planet by less than the width of an atom. Tiny as this distortion was, our instruments felt it. The universe had spoken in a new language, and we had learned to hear it. In that moment, the cosmos became more intimate, its most violent events capable of touching us directly, across unimaginable distances. These signals change how we understand time. When we detect a supernova in a distant galaxy, we are not witnessing an event as it happens. We are seeing the afterimage of a catastrophe that occurred millions of years ago. The star is long dead, its remnants scattered into space, perhaps already forming new stars and planets. Yet its light is only now reaching our eyes. The universe is a museum of ghosts, each signal a preserved moment from a past we can never revisit. To observe the cosmos is to look backward, deeper and deeper into history, until the signals themselves fade into the noise of the primordial universe, when light could not yet travel freely. At the edge of what we can detect lies the cosmic microwave background, the oldest signal we can observe. It is the faint afterglow of the universe's birth, radiation released when the cosmos cooled enough for light to move unimpeded. This whisper from the beginning fills all of space, a nearly uniform background of microwaves, carrying subtle variations that map the seeds of all future structure. Galaxies, stars, planets, and eventually life itself are written into those tiny fluctuations. In this sense, every signal we detect today is part of a long chain of cause and effect that began in the first moments of time. The unknown speaks to us not only from distant places, but from the deepest layers of the past. Yet for all our instruments and equations, signals remain incomplete. They are fragments of stories, not the stories themselves. We infer black holes from their influence on nearby stars, from the radiation of matter falling into darkness, from the tremors of space-time when they collide. But the interior of a black hole remains hidden, sealed behind an event horizon that no signal can cross. There are places in the universe that speak to us only in shadows, where the unknown is not a lack of data, but a fundamental boundary. To listen to the cosmos is to accept that some answers may always remain out of reach, not because we lack intelligence, but because the universe itself has limits on what can be known. Still, we continue to listen. We build larger telescopes, place detectors in orbit, sink observatories beneath mountains and ice. We refine our algorithms, teaching machines to sift through oceans of data, to recognize patterns that human eyes might miss. In the noise of the universe, we search for meaning. In the chaos of signals, we look for order. Each new detection is a small victory against cosmic indifference, a moment when the universe reveals a little more of its hidden structure. There is a quiet intimacy in this act of listening. The signals we receive were not meant for us. A pulsar does not care that we decode its rhythm. A gamma ray burst does not announce itself with intention. Even the cosmic background radiation is not a message in any deliberate sense. Yet by listening, by choosing to pay attention, we transform these blind physical processes into knowledge, and knowledge into understanding. The unknown becomes slightly less unknown, and the universe becomes slightly more familiar. In the end, the signals from the unknown do not simply tell us about distant objects. They tell us about ourselves. They reveal the limits of our perception, the reach of our curiosity, the depth of our need to know what lies beyond the horizon. We are creatures born on a small world, orbiting an ordinary star, in one galaxy among billions. Yet we have learned to feel the tremors of colliding black holes, to catch the faint glow of the universe's first light, to hear the heartbeat of neutron stars across the abyss. The cosmos does not speak in human words, but we have learned its languages of light, particles, and waves. And so we listen, not because the universe owes us answers, but because listening is what makes us human. In the vast, echoing darkness, every signal we catch is a reminder that we are part of a much larger story. A story still being written, one faint whisper at a time. Chapter 3. The Dark Places We Avoid. There are regions of the universe that do not shine. They do not glow in the visible spectrum, do not announce themselves with brilliant flares or rhythmic pulses. They sit quietly between the stars, vast and cold, absorbing light instead of reflecting it. To the human eye, they appear as absences, as holes punched into the fabric of the sky. Ancient stargazers once believed these dark patches were simply empty, voids where creation had failed to reach. But emptiness, it turns out, is one of the rarest things in the cosmos. These dark places are not nothing. They are something immense. Great clouds of dust and gas drift through the galaxy, thick enough to block the light of entire star fields behind them. From Earth, they look like shadows painted across the Milky Way. They are called nebulae of darkness, molecular clouds so dense and cold that even starlight struggles to pass through. Inside them, temperatures fall to just a few degrees above absolute zero. Atoms move slowly. Chemistry changes. Time itself seems to stretch. They are among the coldest, quietest environments in the known universe. And yet, these regions are not tombs. They are wombs. Within the darkness, gravity works patiently. Tiny clumps of matter begin to gather, almost imperceptibly at first. A slight overdensity here, a gentle tug there. Over millions of years, these clumps grow heavier, drawing in more gas and dust from their surroundings. Pressure builds. Heat begins to rise. The darkness thickens around a secret being formed in silence. In the heart of these cold clouds, stars are born. We often imagine creation as something loud and dramatic, as if the universe announces every beginning with fireworks. But starbirth begins in near total quiet. There is no sound in space, no roar of ignition, no crackle of flame. There is only gravity, slowly shaping chaos into structure. A future sun gathers itself in the dark, unseen by any eye, hidden behind curtains of cosmic dust. For millions of years, it exists as a promise rather than a presence. These hidden nurseries remind us of something deeply human. We are drawn to light. We build our cities where lamps and screens push back the night. We associate brightness with safety, with knowledge, with progress. Darkness, by contrast, feels like danger. It feels like the unknown. For most of our history, the dark was where predators waited, where the ground fell away, where certainty ended. Even now, with all our technology, we fill our lives with illumination, pushing shadows into corners as if they were threats that might grow if left unattended. But the universe does not share our fear of darkness. In the cosmos, darkness is not an enemy of creation. It is often the condition for it. Beyond the dark nebulae lie even deeper forms of cosmic shadow. Vast regions of space contain matter we cannot see at all. Galaxies rotate too quickly for their visible mass to hold them together. Clusters of galaxies bend light from objects behind them with a strength that cannot be explained by what we can observe. Something invisible is present, exerting gravity, shaping the large-scale structure of the universe. We call it dark matter, not because it is evil or ominous, but because it does not interact with light in any way we can detect. Dark matter does not shine. It does not absorb light. It passes through ordinary matter as if it were almost not there. And yet, without it, galaxies might never have formed. In the early universe, as matter began to cool and clump together, dark matter provided the scaffolding upon which visible matter could gather. It carved invisible wells in space-time, gravitational valleys that ordinary atoms could fall into. Every spiral arm, every glowing nebula, every star-studded galaxy may owe its shape to something we cannot see. We stand in a universe whose architecture is built largely by an unseen presence. Most of the mass that holds galaxies together is dark. Most of the matter in the cosmos is invisible. The stars we admire, the planets we measure, the atoms that make up our bodies are only a small fraction of what exists. We live in the light, but we are surrounded, structured, and guided by the dark. And then there are the darkest places of all, where even light itself cannot escape. When massive stars reach the end of their lives, they die in violence. Their cores collapse under their own weight, crushing matter into densities beyond imagination. If the core is massive enough, no known force can stop the collapse. Gravity wins completely, warping space-time so severely that a boundary forms around the collapsed core. Beyond this boundary, escape is impossible. Not for particles, not for radiation, not even for light. A black hole is born. For a long time, black holes existed only in equations, ghostly solutions to the mathematics of gravity that many scientists doubted could be real. The idea that nature would allow something so extreme felt unsettling, almost obscene. A region of space where information might vanish, where the laws of physics as we know them seemed to break down. It was easier to believe that the universe would never permit such a thing to exist. But the universe is under no obligation to comfort us. We now know that black holes are common. They hide at the centers of most galaxies, including our own. The heart of the Milky Way contains a supermassive black hole with a mass millions of times greater than that of the Sun. It is quiet most of the time, not actively consuming stars, but its gravity governs the motion of countless stellar systems around it. The gentle arc of our galaxy's spiral arms, the slow dance of stars across the night sky, all unfold within a gravitational landscape shaped by a darkness at the center. Black holes challenge our deepest intuitions. They are not cosmic vacuum cleaners, roaming the universe and devouring everything in their path. From a distance, they behave like any other object of the same mass. A planet could orbit a black hole just as it orbits a star, if it were far enough away. The terror of black holes lies not in their appetite, but in their finality. Cross the boundary, and the concept of elsewhere ceases to apply. The future becomes inescapable. Space-time curves inward so steeply that all possible paths lead deeper into the dark. Yet even black holes are not purely places of destruction. Around them, matter can heat to extraordinary temperatures, releasing vast amounts of energy before crossing the point of no return. Some of the brightest objects in the universe are powered by material falling into black holes. Quasars, visible across billions of light years, outshine entire galaxies with light produced at the edges of these cosmic abysses. From the brink of darkness comes some of the most intense illumination the universe has ever known. There is another darkness that permeates everything, not localized in clouds or collapsed stars, but woven into the very fabric of space itself. As the universe expands, it does not simply coast outward under its original momentum. The expansion is accelerating, driven by a mysterious influence we call dark energy. Unlike gravity, which pulls matter together, this force seems to push the universe apart. Galaxies drift away from one another at ever-increasing speeds. The space between clusters grows emptier, colder, more silent. We do not know what dark energy is. We can measure its effects, chart its influence across cosmic history, but its nature remains elusive. It might be a property of empty space itself, a pressure inherent to the vacuum. It might be something even stranger, a field that fills the cosmos with a repulsive force. Whatever its origin, dark energy will shape the ultimate fate of the universe. If it continues to dominate, galaxies beyond our local group will eventually recede beyond the reach of any signal we could send or receive. The night sky will grow lonelier. Distant lights will fade, not because the stars have died, but because space has stretched too far for their photons to ever reach us. In timescales that dwarf human history, the universe may become a place of vast, cold darkness, punctuated only by isolated islands of stars bound together by gravity. The grand web of galaxies we see today, stretching across billions of light years, will thin into solitude. The future of the cosmos, under the rule of dark energy, appears to be a slow fading into silence. And yet, even here, darkness is not simply an ending. The same expansion that carries galaxies away also preserves the memory of a universe that was once hotter, denser, and more connected. The cosmic microwave background, the faint afterglow of the Big Bang, still permeates all of space, a whisper of light left over from a time when the universe itself was opaque, when photons could not travel freely because matter and radiation were locked together in a searing plasma. The universe began not in light, but in a kind of blinding density that only later cooled enough to allow light to move. Darkness and transparency emerged together, two sides of the same cosmic evolution. Our avoidance of dark places is deeply rooted in our biology and psychology. We evolved under a sky that alternated between day and night, safety and vulnerability. Darkness concealed dangers. It hid predators. It masked the edges of cliffs and the depths of forests. In the dark, our senses are less reliable, our confidence diminished. Even today, we speak of ignorance as darkness, of understanding as illumination. To know is to see the light. To be uncertain is to be in the dark. But the universe invites us to reconsider these metaphors. Some of its greatest truths reside not in the brightest beacons, but in the shadows between them. The dark nebulae that blot out starlight are the cradles of future suns. The invisible matter that binds galaxies together is the unseen architect of cosmic structure. The black holes we fear are engines of some of the universe's most powerful displays of energy. The dark energy that stretches space may be guiding the long-term destiny of everything that exists. We avoid the dark because we fear what we cannot see. But what we cannot see is not necessarily empty, and it is not necessarily hostile. Often, it is simply unexplored. In our own lives, there are dark places we avoid as well. Questions without answers. Grief without resolution. Fears we do not name. Like the cosmic shadows, these inner darknesses can feel like voids, like absences of meaning or hope. We move around them, preferring the familiar light of certainty. Yet growth, like star formation, often begins in obscurity. New understanding takes shape in silence. The parts of ourselves we do not yet see clearly may be the very places where future light is forming. The universe does not hurry. It allows gravity to work over millions of years in cold, hidden clouds. It allows unseen matter to shape galaxies over cosmic time. It allows the slow, relentless stretching of space to redefine the future of everything. In this vast patience, there is a quiet lesson. Darkness is not always something to conquer. Sometimes it is something to enter, to study, to learn from. When we turn our instruments toward the dark places of the cosmos, we are not merely seeking to banish shadow with knowledge. We are learning to see differently. Infrared telescopes peer through dust that blocks visible light, revealing the warm glow of forming stars. Gravitational detectors sense the ripples in space-time produced by merging black holes, translating invisible violence into measurable signals. Particle experiments deep underground search for traces of dark matter passing silently through Earth itself. We extend our senses beyond their natural limits, not to destroy the darkness, but to understand what lives within it. The dark places we avoid are not outside the story of the universe. They are the story. They are where structure forms, where forces we do not yet fully comprehend shape the grand design of reality. Light may show us the surface of the cosmos, but darkness reveals its foundations. To look into these regions is to confront our own limits. We are a species that learned to measure the stars by the light they give off, and now we must learn to measure the weight of what gives off no light at all. We are explorers of a universe that is mostly invisible, mostly silent, mostly dark. And yet, within that darkness, everything we know has taken shape. The night sky is not merely a scattering of bright points on a black canvas. It is a complex landscape of shadows and glows, absences and presences, visible matter suspended within an unseen framework. When we lift our eyes to the stars, we are also gazing into vast regions of darkness that cradle those lights, bind them together, and guide their motion through space and time. Perhaps the reason these dark places unsettle us is not because they are empty, but because they remind us how much of reality lies beyond our immediate perception. They whisper that our picture of the universe is incomplete, that the most important forces may not announce themselves with brilliance. They invite humility. They invite curiosity. In the end, the dark places we avoid are not boundaries to knowledge, but doorways. They mark the edges of what we currently understand, the frontiers where mystery still reigns. To step toward them is not to step into nothingness, but into a deeper, richer sense of what the universe truly is. Chapter 4: Creatures of the Cosmos Speculative. Beyond the faint shimmer of distant galaxies, in the depths of the universe, where light itself struggles to travel, one of humanity's most profound questions lingers. Are we alone? For centuries, our understanding of life has been anchored to the small, fragile biosphere of Earth. But the universe offers a far grander stage, one where the very laws of biology may stretch beyond our imagination. In this boundless expanse, life, if it exists, may take forms unimaginable, creatures sculpted by alien physics, by atmospheres heavier than steel, by suns that burn in colors unknown to the human eye. Speculative science challenges us to envision life not as we know it, but as it could be. Perhaps there are beings that float through the thick clouds of gas giants. their translucent bodies glowing faintly with bioluminescent pulses, drifting with currents stronger than any ocean on Earth. These creatures might not have eyes or mouths in any familiar sense. Instead, they could perceive the world through electromagnetic fields, reading the subtle vibrations of charged particles as easily as a human reads a page. Communication, survival, reproduction, these could occur entirely through patterns of light, sound, or even chemical waves that ripple invisibly through their atmosphere. Consider worlds orbiting red dwarfs, small, dim stars whose light is far weaker than our sun. Any life that evolved there would have adapted to near-perpetual twilight. Eyes may be replaced by sensory organs attuned to infrared or ultraviolet radiation, capable of perceiving the feeble heat of neighboring organisms, or even the faint glow of minerals under alien skies. Some planets may host life on floating islands of ice or liquid methane lakes, where gravity is weaker and chemical reactions slow, allowing creatures to grow to massive sizes without collapsing under their own weight. On Earth, evolution is rapid and brutal, yet on these distant worlds, a single organism might persist unchanged for millennia, moving through its environment as slowly and deliberately as a drifting nebula. Speculation about cosmic life often turns toward the extreme. Could there be beings that exist without a physical body at all? In the near vacuum of interstellar space, where atoms are few and radiation is deadly, life might survive as a pattern of energy. These entities could be composed of plasma, held together by magnetic fields, traversing light years while consuming cosmic radiation as sustenance. To us, they would be invisible, except perhaps as fleeting distortions in the delicate balance of particles that drift between the stars. These are creatures that would see and think, yet never touch, never breathe, never exist in the form we recognize as life. On planets with dense, crushing atmospheres, evolution might favor extreme resilience. Creatures here could be armored against acid rains and constant storms, with multiple redundant organs to survive catastrophic failure. Limbs may extend and contract like living hydraulic systems, muscles strengthened by exotic biochemistry. Their skin might refract light in dazzling patterns, both as camouflage and as a form of communication, a language written in color and motion, visible only to those who understand it. Perhaps some of these beings are solitary predators, stalking the clouds for unsuspecting prey, while others move in massive, coordinated swarms, a single consciousness spread across thousands of bodies. Speculative biology also leads us to the oceans of distant worlds. Underneath layers of ice, heated by tidal forces or radioactive decay, lie seas that may teem with life. In such dark, pressurized depths, light is irrelevant, and organisms could rely on chemical energy alone. These creatures might drift like jellyfish, their translucent bodies pulsating as they absorb energy from hydrothermal vents. Or perhaps they resemble massive, undulating forests of soft tissue, anchored to the seabed, interacting with one another through vibrations and pulses that travel through water. The alien oceans may be home to life cycles entirely different from our own, where reproduction is a complex chemical process and intelligence may manifest as a collective phenomenon rather than individual minds. Even the concept of size becomes malleable in the cosmos. On planets with low gravity, organisms might grow to colossal proportions, their bones unnecessary as structural support, their movements slow, almost majestic. Conversely, on worlds with intense gravity, life may remain tiny, adapting to survive under crushing pressures and extreme densities. The interplay between environment and biology is a constant negotiation, a cosmic dance shaping life into forms that may be simultaneously familiar and utterly alien. We are also compelled to imagine intelligence, a force as enigmatic as life itself. Alien cognition could be beyond our comprehension, arising not from brains, but from distributed networks of cells, from energy patterns, or from chemical matrices. Intelligence may not center on tools or communication. It may manifest as an acute awareness of environmental rhythms, a sensitivity to cosmic cycles, or an ability to harness energy flows we cannot even detect. Civilization, if it exists, might leave no technological signatures we would recognize, its achievements hidden in chemical imprints, magnetic anomalies, or subtle changes to its planetary environment. The search for extraterrestrial life is constrained by our own biases. We look for Earth-like planets, for atmospheres similar to our own, for water as a solvent, assuming that what works here must work elsewhere. Yet the universe is vast and indifferent to our expectations. Life may thrive in conditions lethal to us, in atmospheres of ammonia, in oceans of liquid hydrocarbons, in temperatures hundreds of degrees below freezing, or thousands above. Our narrow vision risks missing the grand tapestry of life, the creatures that inhabit corners of the cosmos where humans may never set foot. Some speculative scientists even ponder the possibility of multidimensional organisms, entities existing partially in dimensions beyond our perception, interacting with our universe only through faint, fleeting effects. We might detect them indirectly as strange gravitational anomalies, fluctuations in light, or shifts in quantum particles. To these creatures, our reality could be as tangible as a shadow passing across a wall. They may observe us with curiosity or indifference, entirely incapable of communicating in ways we would understand. The cosmos may also host symbiotic or collective forms of life, communities where individual organisms are merely components of a greater consciousness. These could be networks of genetically identical units, spreading across planetary surfaces or floating freely in space, their interactions forming a single, coherent intelligence. Their motivations, their perception of time, their very understanding of existence might be fundamentally alien, shaped by experiences far removed from anything conceivable in human history. Yet, amidst this speculation, there is a thread of humility. Life, in any form, represents persistence against the void, a triumph of order over chaos. The creatures of the cosmos, if they exist, demonstrate that existence itself is a rare, fragile miracle. They challenge our assumptions, our anthropocentric vision of intelligence, our narrow definitions of survival. They remind us that the universe is not a stage for humanity alone, but a theater of endless possibility, a realm in which life may emerge in ways that defy imagination. Speculative as it may be, contemplating these cosmic creatures is not merely a flight of fancy. It informs the way we search for life, shaping the missions we design, the instruments we build, the signals we seek. Every new exoplanet discovered, every unusual chemical signature detected in an atmosphere, every anomaly in the faint light of a distant star expands the playground in which life might exist. We begin to understand that the universe is not empty. It is full of potential. Each planet, moon, or asteroid a possible host to forms of life we cannot yet perceive. Perhaps one day, humans will encounter these beings, and the encounter will redefine what it means to be alive. We may find creatures that live for centuries in silent meditation, or beings that reproduce in microseconds, or intelligence spread across trillions of microscopic organisms. We may see beauty beyond comprehension, forms that challenge the very definitions of shape and motion, of color and sound, of consciousness itself. And in that moment, we will realize that life is not a property of Earth alone, but a fundamental expression of the universe, manifesting in ways both subtle and spectacular. In imagining the creatures of the cosmos, we are also imagining ourselves. We see reflected in them our own curiosity, our own need to explore, to question, to reach beyond what is familiar. We are bound to the stars not merely by gravity or chance, but by the profound urge to know, to encounter, to understand the infinite diversity that life, in any corner of the universe, might take. The cosmos, in its silence and its vastness, whispers of creatures that may be watching, drifting, thinking, or simply existing. Their forms may be grotesque or elegant, terrifying or wondrous, incomprehensible yet bound by the same laws that govern our tiny world. And in contemplating their existence, we are reminded of our place, not at the center of the universe, but as a part of its eternal unfolding, observers of a grand experiment whose results may never be fully known. The creatures of the cosmos remain hypothetical, speculative, unconfirmed by observation. Yet in their possibility lies a profound truth. Life is adaptable, resilient, and inventive. It is a force that does not submit easily to limits, and its manifestations may be as varied as the galaxies themselves. To explore these possibilities is to explore the outer edges of imagination, to push the boundaries of science, and to confront the infinite complexity that lies beyond the next star, the next planet, the next cosmic dawn. The universe is alive in ways we cannot yet measure. In the shadows of nebulae, in the depths of alien oceans, in the faint light of dying stars, there may exist beings whose existence challenges every assumption we hold. They are reminders that the cosmos is not ours alone, and that the search for life is, at its core, a search for understanding of nature, of creation, and of ourselves. And so we continue to look outward, driven by curiosity and wonder. For the creatures of the cosmos, whether gas-bound specters, ice-dwelling leviathans, or radiant patterns of energy, are not just stories or speculation. They are possibilities, invitations to expand our minds, to embrace the unknown, and to recognize that life, in all its forms, is the universe's most profound secret, and perhaps its most enduring gift. Chapter 5: Black Holes. Doors or graves. Black holes are the ultimate paradox of the cosmos. They are at once terrifying and seductive, objects that challenge everything we think we know about physics, time, and the limits of human imagination. To call them merely holes is to underestimate their complexity. They are dense, dark, and inscrutable, regions of space where gravity is so intense that nothing, not even light, can escape. Yet despite their name, black holes are far from empty. They are arenas of extreme energy, sculptors of galaxies, and perhaps gateways to realms beyond our understanding. The story of black holes begins with stars. Every star, like our sun, is a furnace of nuclear fusion, fusing hydrogen into helium, producing light and heat that bathes its surroundings in life-giving energy. But stars are mortal. When a star far more massive than our sun exhausts its fuel, its core collapses under the weight of its own gravity. The outer layers are expelled in a violent supernova, leaving behind a core so dense that it collapses into a singularity, a point where our current understanding of physics breaks down. The singularity is surrounded by an event horizon, the invisible boundary beyond which nothing returns. Crossing this line is like stepping off the edge of the universe. From our perspective, all is lost, yet within, mysteries abound. Black holes come in many forms. Stellar black holes, born from collapsing stars, are relatively small but extraordinarily dense. Supermassive black holes, however, lurk at the centers of galaxies, including our own Milky Way. They contain millions or even billions of times the mass of a sun, yet they occupy a space no larger than our solar system. How these giants form remains one of the most profound questions in astrophysics. Some theories suggest that they grew from the merger of smaller black holes, or perhaps they are relics of the early universe, seeds from which galaxies sprouted. They anchor the galaxies around them, their immense gravity shaping the stars, gas, and dust that orbit in delicate, swirling patterns. Without them, galaxies as we know them might not exist at all. To imagine a black hole is to confront a kind of cosmic horror. Picture a point in space where time itself is stretched and twisted. Near the event horizon, time slows. A clock approaching a black hole would tick ever more slowly, appearing frozen to an outside observer, while for someone daring to fall in, the journey would be swift, fatal, and unknowable. The very fabric of reality warps under the pull of extreme gravity. Light is bent, space is curved, and the line between past, present, and future blurs. Some physicists describe black holes as the ultimate laboratory of the universe, places where general relativity and quantum mechanics collide, where the laws of physics are pushed to their breaking point. Yet black holes are not merely destructive. They are engines of creation. When matter falls toward a black hole, it forms a swirling accretion disk, heated to millions of degrees, emitting intense X-rays and gamma rays. These jets of energy can span thousands of light years, shaping entire galaxies. In this way, black holes are paradoxically both graveyards and creators, consuming matter while fueling the cosmos with energy, stirring the cosmic cauldron that gives birth to stars and planetary systems. They are the dark alchemists of the universe. The observation of black holes has long been a challenge. By their very nature, they emit no light. Our understanding relies on the effects they have on their surroundings, the way stars orbit an unseen mass, the gravitational lensing that bends the light of distant objects, the radiation emitted by infalling matter. In 2019, humanity captured the first direct image of a black hole's shadow in the galaxy M87, a moment that marked a new era in astronomy. It was a glimpse into the invisible, a testament to human ingenuity, and a reminder that even the darkest corners of the universe can be unveiled through persistence, mathematics, and vision. Despite decades of study, black holes remain enigmatic. Some theories suggest that the singularity at their center might not be a point of infinite density, but a doorway to another region of space-time, a wormhole, perhaps connecting distant parts of the universe. Could black holes be passages rather than prisons? Could they harbor other universes, or fold time upon itself in ways that allow travel across unimaginable distances? These ideas remain speculative, yet they tantalize the mind, urging us to reconsider what is possible in a cosmos far stranger than we can easily comprehend. Hawking radiation, predicted by Stephen Hawking in the 1970s, added another layer of mystery. Black holes, it seems, are not entirely eternal. They emit a faint radiation, losing mass slowly over astronomical timescales, and may eventually evaporate entirely. If this is true, black holes are not final graves, but transient phenomena, their existence a delicate balance between creation and destruction, permanence and impermanence. Even in their immense darkness, they whisper of the fleeting nature of all things, including the universe itself. The influence of black holes extends beyond the scientific. They touch our imagination, inspiring myths, metaphors, and existential reflection. They are the ultimate unknown, a reminder of how little we truly grasp of the universe we inhabit. To gaze upon a black hole is to confront the sublime, the combination of awe and terror that Hegel described as the hallmark of the human encounter with the infinite. They provoke questions about destiny, mortality, and the limits of knowledge, mirrors of our own desire to explore, to understand, and to endure. Even as we study them, black holes challenge our most cherished assumptions. They force physicists to confront the paradoxes of quantum mechanics and general relativity, the tension between the microscopic and macroscopic laws of the universe. The information paradox questions whether information that falls into a black hole is destroyed or preserved, an enigma that has sparked decades of debate and profound theoretical insights. Black holes are not merely cosmic curiosities. They are crucibles of understanding, gateways to a deeper comprehension of reality itself. Black holes also teach us humility. They are indifferent to human life, to civilizations, to our ambitions and fears. Their existence is not bound to our perception. They are older than galaxies, older than the sun, relics of cosmic processes that predate Earth itself. Yet in their indifference lies a strange form of beauty. They remind us that the universe is vast, complex, and often incomprehensible, but that it also rewards curiosity and perseverance. By studying them, we glimpse the extraordinary order hidden within seeming chaos, the principles that govern the cosmos on its grandest scales. What does the future hold for our understanding of black holes? The next decades promise deeper insight as gravitational wave astronomy opens new avenues of exploration. The ripples in space-time detected when black holes collide provide information about mass, spin, and the structure of space-time itself. Missions to capture even more detailed images, to map the environment near the event horizon, will continue to reveal the dynamics of these enigmatic giants. And perhaps, someday, we may unravel the deeper truths that they guard, the secrets of space, time, and the fabric of reality itself. Black holes are, in essence, both doors and graves. They consume, destroy, and erase, yet in doing so, they create, energize, and illuminate. They are extremes of nature, laboratories of physics, and canvases of the imagination. They are reminders of our limitations and our potential. To understand black holes is to confront the profound mysteries of existence, the paradox of life and death writ across the cosmos. They are not merely celestial phenomena. They are symbols of the infinite, the unknowable, and the sublime, places where the universe whispers its deepest secrets to those who dare to listen. In the end, black holes defy simple classification. They are not merely cosmic monsters, nor are they mere cosmic windows. They are both and more. They are thresholds, points of transition where the known laws of physics falter, and where the imagination must stretch to comprehend what might lie beyond. They are the ultimate reminder that the universe is a place of wonder and terror, a realm in which we are both infinitesimally small and infinitely capable of exploration and understanding. In confronting black holes, we confront ourselves, our curiosity, and the endless possibilities of the universe. Chapter 6. Time does not flow here. Time, as we experience it, is a relentless river. It carries us from birth to death, marking every heartbeat, every fleeting thought, every sigh with a precision that feels absolute. We measure it in seconds, in minutes, in centuries. Yet in the vast expanse of the universe, this river is neither constant nor universal. In certain realms, time behaves not as a smooth continuum, but as a fluid, malleable phenomenon, stretching and compressing in ways that defy our intuition. Here, in the presence of extreme gravity and unimaginable density, the rules that govern our lives unravel, revealing a cosmos where time itself is no longer a given. Consider the vicinity of a black hole. To an observer far from its influence, the black hole appears as a dark abyss, a point of infinite gravity. But closer to its event horizon, something extraordinary happens. Time slows. The closer one gets to this boundary, the slower time ticks relative to the rest of the universe. What might feel like a single hour for a visitor near the edge could translate to centuries for someone observing from afar. Here, the human lifespan collapses against the vastness of cosmic time. A moment can stretch into eternity. To step into such a region is to step out of the rhythm of the universe as we know it, into a place where cause and effect begin to blur. Einstein's theory of general relativity, formulated over a century ago, predicts these effects with stunning precision. Massive objects warp the very fabric of space-time, creating pockets where time dilates, where light curves, and where reality itself seems to hesitate. It is a scientific truth that challenges our most basic understanding of existence. For civilizations far advanced beyond our own, who might traverse near these regions, time may be perceived not as a line, but as a landscape, folded, twisted, and layered upon itself. Here, a single voyage could outlast the lifetime of a star. Yet black holes are not the only arenas where time refuses to obey. Even in the absence of such extremes, the expansion of the universe stretches the cosmic clock. Galaxies receding at immense speeds experience a phenomenon known as cosmological time dilation. Light from the most distant stars does not merely travel across space. It is stretched, elongated by the very expansion of space-time, carrying with it signals from a past that no longer exists in the present form. To peer into these depths is to witness the universe not as it is, but as it was. And as we observe, we understand that our concept of simultaneity, the idea that two events can occur at the same time, is a fragile illusion. Across the cosmos, what is now here may already be yesterday there, and tomorrow elsewhere may have passed without our notice. In certain cosmic environments, this distortion of time takes on an almost surreal character. Neutron stars, the remnants of collapsed stellar cores, spin at dizzying velocities. Their density is so extreme that a teaspoon of their matter weighs more than a mountain. Around these stars, time itself contorts. Clocks would tick unevenly, and processes we consider instantaneous would unfold with staggering slowness. Radiation emitted from their surface is subject to gravitational time dilation, and any being or instrument caught in such a field would experience a reality entirely alien to our own. The ordinary sequence of events, cause, effect, life, decay, becomes uncertain. The thought experiments that arise from these extremes are haunting. Imagine a spacecraft venturing near a black hole. The crew might perceive days passing in the void, while the rest of the universe races forward by decades, centuries, or millennia. They would return not merely to a different location, but to a world altered beyond recognition. Civilizations they knew might have vanished, stars might have burned out, and landscapes that were once familiar would exist only in memory. Time, once the guardian of continuity, has betrayed them. Even within our solar system, time's malleability is detectable, though far subtler. Experiments using precise atomic clocks aboard satellites reveal tiny discrepancies between clocks on Earth and those in orbit. GPS systems, which many of us rely upon daily, must account for these variations. Without correcting for the effects of both gravitational and velocity-induced time dilation, our technology would fail. Humanity experiences this as minor inconvenience or mathematical correction, but it is a profound demonstration that even the gentle pull of our planet distorts the fabric of time, and that relativity is not merely abstract theory, it is practical truth. Time's mutability also invites speculation on questions that straddle science and philosophy. If a civilization could navigate regions where time stretches infinitely, could it achieve what we call immortality? Not of the body, but of experience? Could knowledge and memory persist, untouched by the erosion of years? Conversely, in regions where time races ahead, could entire worlds evolve and perish before a single conscious mind could grasp their transformation? The universe presents scenarios where life and death, creation and destruction, are not absolute events but relative phenomena, contingent on position and motion in the cosmic landscape. These extremes reshape our perception of causality. In environments of intense temporal distortion, the usual sequence of cause and effect can become ambiguous. Signals sent from one location may arrive in another far off in time, appearing to precede their origin. Events separated by decades or centuries in ordinary experience could unfold simultaneously within warped space-time. For beings capable of perceiving these anomalies, the universe might feel more like a tapestry, a multidimensional web of interwoven moments, rather than a linear progression of seconds. Time, far from a fixed river, is a vast, flowing ocean, and we are mere drifters on its surface. The concept of entropy, often described as the arrow of time, also becomes unstable in these conditions. Entropy, the measure of disorder, defines the direction from past to future in our everyday reality. Heat flows from hot to cold, objects age and decay, stars burn through their fuel. But when time itself is stretched or compressed, entropy becomes relative. Processes we consider irreversible may appear frozen, reversed, or infinitely slowed. In the heart of a black hole, where time ceases for all practical purposes, the very notion of progression loses meaning. There is no before, no after. Only a singular, eternal moment of collapse. Yet, as terrifying as this may seem, it is also a source of cosmic poetry. Time, in its malleability, reveals the grandeur of the universe and the fragility of our perception. It teaches us that our lives, our histories, our civilizations are not merely sequences of events, but fleeting glimpses into a much larger, more intricate reality. The stars themselves may witness eons of change while we blink through centuries. Every moment becomes precious, every second a miracle of perception against the backdrop of timelessness. And within this framework, the human imagination stretches. Scientists and thinkers speculate about ways to traverse these temporal landscapes. Wormholes, hypothetical tunnels connecting distant points in space-time, could provide shortcuts not only through space but potentially through time itself. Though purely theoretical, such constructs highlight that the universe may harbor possibilities far beyond our comprehension. We might one day glimpse the past as clearly as the present, or traverse vast futures, witnessing the ultimate fate of stars and galaxies. For now, these remain dreams, anchored in equations and hypotheses, but their existence whispers of a universe more wondrous than our limited experience allows. Even as we explore these extreme possibilities, we are reminded of our intimacy with time. Our lives are finite, our memories fragile, our understanding partial. Yet this very finitude gives meaning to our observations. Knowing that time flows differently elsewhere makes each measurement, each discovery, each moment of awareness profoundly significant. We grasp that while time is not absolute, our experience of it, the rhythm of our heartbeat, the cadence of thought, is a lens through which we perceive the universe's vastness. The ultimate paradox is this: in a universe where time does not flow uniformly, our perception of it remains linear, measured, and poignant. We age, we change, we watch stars die and be reborn, yet we cannot step outside the arrow of our own experience. Time, both pliable and inescapable, is the stage on which the story of life unfolds. It binds us to the cosmos even as it twists and bends, reminding us that we are both fleeting observers and participants in a grand, intricate drama. In these regions where time is stretched, frozen, or accelerated, we confront a truth both humbling and exhilarating. The universe is not built around our understanding. It does not conform to our instincts or our clocks. It operates according to principles vast and abstract, where time is neither sacred nor immutable, but a variable woven into the fabric of space-time itself. To study it is to glimpse the extraordinary, to understand that what we take for granted, days, years, lifetimes, is merely a local rhythm, one heartbeat in the symphony of the cosmos. And yet, as we peer into these regions, we sense a strange kinship. Though time may flow differently, the laws of physics remain. Matter persists, energy transforms, and the principles of causality, however warped, endure. It is a universe that is simultaneously alien and familiar, terrifying and beautiful. To experience time here is to understand the impermanence of all things and the enduring constancy of the universe itself. Time does not flow here, but consciousness persists. Memory, observation, and wonder continue to mark the passage of existence. The human mind, equipped with curiosity and imagination, can traverse this distorted reality, mapping it in thought even if we cannot inhabit it physically. In doing so, we stretch the boundaries of perception, learning that our comprehension of the cosmos and of ourselves is inseparable from the fluidity of time. In the end, to dwell in a universe where time is not universal is to embrace paradox. We are bound by our biology, our planet, our clocks, yet we can conceive of realities where a second can stretch into eons and centuries collapse into instants. Time, both malleable and absolute, fleeting and eternal, becomes not merely a measure, but a story, a narrative that flows through black holes, across galaxies, and into the hearts and minds of those who dare to contemplate it. Here, at the edge of understanding, we confront the sublime. That time, which we take for granted, is neither fixed nor finite, but a vast and untamed ocean, and we are all travelers upon its ever-changing currents. Chapter 7. Worlds That Shouldn't Exist. In the vast theater of the cosmos, most planets seem predictable, following the rhythms of gravity and the quiet logic of orbital mechanics. Yet, scattered across the galaxy are worlds that defy expectation, planets that exist in conditions thought impossible, landscapes sculpted by forces that challenge every assumption we hold about the nature of matter and life. These are worlds that shouldn't exist, yet they do. Their very presence is a reminder that the universe has a creativity far beyond human comprehension. Imagine a planet so close to its star that it completes an orbit in a single day. Its surface is a molten ocean of rock, where temperatures soar beyond any material we can fabricate on Earth. Winds race across its surface at thousands of kilometers per hour, and metal rains from a sky glowing with the fire of the star's fury. This is not science fiction. It is reality. Planets like these, often called lava worlds, exist in the searing light of their suns, resilient against the odds, forced into survival in an environment that would vaporize anything familiar. Other worlds challenge physics in subtler ways. There are planets that are so dense, so massive, that their gravity crushes the air around them into a layer hundreds of kilometers thick. On these planets, a human-sized object would feel the weight of a mountain pressing down from all directions. Some planets, though smaller than Earth, hold more mass than Jupiter, compacted into an almost impossible volume. The atoms themselves are squeezed together under pressures we cannot replicate, forming exotic states of matter that exist only in the hearts of these alien worlds. Then there are the gas giants that orbit perilously close to their suns. Known as hot Jupiters, these planets are enormous, but their heat is extraordinary. Clouds swirl in kaleidoscopic storms, composed of vaporized rock and metals, dancing at temperatures hotter than the surface of our sun. Winds tear across these planets at supersonic speeds, carrying iron and silicates in a cycle of perpetual chaos. To imagine a sky like this, where rain burns as it falls, is to glimpse the universe's indifference to our notions of habitability. Yet some of the most confounding worlds are those that exist where they seemingly cannot. Rogue planets, untethered from any star, drift in the darkness, cold and lonely. In the eternal night between galaxies, these nomadic worlds wander without light, without warmth, yet they persist. Some retain atmospheres, thick blankets of hydrogen and helium, keeping them from collapsing under the pressure of their own gravity. Others may harbor oceans heated not by starlight, but by the decay of radioactive elements deep within their cores. Life, if it exists here, would be unimaginable. Creatures that never see a sun, that thrive in perpetual darkness, that navigate the universe by magnetic fields and chemical gradients. In our solar system, too, we glimpse hints of worlds that defy expectation. Venus, shrouded in clouds of sulfuric acid, spins backward on its axis, a world of crushing pressure and greenhouse fury. Its surface is a labyrinth of volcanic plains and towering mountains, where a day lasts longer than a year, and yet, despite these extremes, we continue to study it, seeking signs of chemical mysteries in its toxic air. Mercury, scorched by the sun, has water ice in its permanently shadowed craters, a paradoxical existence that underscores the complexity of planetary formation and survival. Exoplanets discovered by the Kepler and TESS missions reveal even stranger configurations. Some orbit two stars, caught in the gravitational ballet of a binary system, their skies lit by twin suns. Their days and nights fluctuate unpredictably, their seasons driven not by axial tilt, but by the shifting alignment of stars. Others orbit pulsars, the remnants of exploded stars, enduring radiation that would sterilize anything known to life. The mere fact that planets exist here forces astronomers to reconsider the resilience of planetary systems and the tenacity of matter itself. Then there are planets composed almost entirely of diamond, crystallized under pressures so intense that carbon, the very foundation of life on Earth, has been transformed into gemstone. Imagine standing on a surface that sparkles with brilliance, not through artistic design, but through the inexorable laws of physics. These worlds are silent monuments to the extremes of chemistry, the hidden creativity of atomic interactions under conditions far removed from our human experience. Other planets boast colors and atmospheres that seem ripped from a dream. Methane skies burn blue or orange, ammonia clouds swirl in violent storms, and surfaces are painted with frozen gases in patterns of unimaginable complexity. On some, lightning dances endlessly across skies of electric purple, and storms rage with energies that dwarf every hurricane known to Earth. On others, the ground is coated in crystalline salts, reflecting starlight in blinding brilliance, a landscape both beautiful and deadly. Even the most barren-looking planets can harbor hidden contradictions. Beneath frozen exteriors, oceans churn in subterranean darkness, warmed by radioactive decay and tidal forces. These oceans may host chemical gradients capable of supporting life, microbial chemistries that have no need for sunlight, but thrive on energy hidden in the rocks themselves. Europa, Enceladus, and other icy moons in our solar system are examples, their surfaces betraying nothing of the potential ecosystems below. The universe's laws allow for survival in the most hostile places, for life to cling where it seems impossible. There are worlds where time itself may stretch or compress in subtle ways, where gravitational interactions cause tidal locking, leaving one hemisphere in eternal daylight while the other lies in perpetual night. Seasons can last centuries, years can stretch into decades, and the passage of time is a strange, alien concept to any hypothetical observer. On some planets, winds erode mountains not over millions of years, but over mere decades, reshaping landscapes with the urgency of storms unmatched on Earth. These processes render the notion of a static planet meaningless. Every surface is a theater of unceasing transformation. In some cases, the orbits of these planets themselves are puzzles. Highly elliptical paths fling them alternately close and far from their stars, subjecting surfaces to extremes of freezing cold and molten heat, sometimes in a single orbit. Others orbit in resonance with neighboring planets, locked in gravitational choreography, each tug and pull stabilizing the system against chaos. The more we discover, the more we realize that our own solar system's seeming order is a fragile exception, a rare balance in a universe of violent extremes. The chemical makeup of these worlds also defies expectation. Some planets are dominated by metals and silicates, their surfaces rich with iron and magnesium, while others are almost entirely gaseous, with cores that may be metallic hydrogen or exotic states of matter we cannot replicate. The variety challenges not only our understanding of planet formation, but also the very definition of what it means to be a planet. In this context, Earth is just one iteration among countless permutations, a familiar model in a library of near-infinite creativity. These worlds also expand the boundaries of our imagination for life. If life exists elsewhere, it may thrive in conditions we would consider lethal. Organisms could live in atmospheres of methane or ammonia, in clouds of toxic chemicals, in the crushing depths of gas giants, or under frozen crusts of ice. Biology, shaped by the pressures of extreme environments, could produce forms, behaviors, and chemistries that would appear alien beyond comprehension. Our search for life, therefore, must be expansive, imaginative, and unbound by terrestrial bias. Even more disorienting are planets that do not orbit a star at all, drifting silently through interstellar space. In these realms, temperatures are near absolute zero, the darkness unbroken for billions of years. Yet models suggest that some rogue planets may still host pockets of liquid water, warmed by internal heat or radioactive decay. Life here would be a whisper, a faint chemistry operating without light, a testament to persistence against unimaginable odds. These wanderers remind us that the universe does not care about comfort or familiarity. It thrives on variation, extremes, and resilience. Ultimately, these worlds that shouldn't exist are lessons in humility. They are reminders that the universe is not constrained by human expectation. Each discovery, each strange orbit or impossible chemistry, expands our sense of what is possible. The cosmos is an artist unconcerned with convention, sculpting planets, moons, and skies with a freedom that mocks our desire for predictability. And in contemplating these extraordinary places, we confront the limits of our imagination, the narrowness of our assumptions, and the staggering scale of the unknown. In the vast, dark stretches between stars, there are countless worlds yet unseen, each with its own story written in ice, rock, gas, or fire. Some will be beautiful, some terrifying, all remarkable in their defiance of expectation. They challenge not only our scientific understanding, but also our capacity to dream. For every planet that obeys the rules we know, there are others that rewrite them entirely, existing in a state of sublime contradiction. The universe is far stranger than we can ever imagine, and its wonders are only beginning to reveal themselves to those who dare to look beyond the familiar. As we catalog these impossible worlds, chart their orbits, measure their atmospheres, and model their compositions, we glimpse the sheer diversity of creation. Some are blazing infernos, others frozen wastelands. Some drift alone in darkness, others whirl in the embrace of multiple stars. Each planet is a laboratory of extremes, a testament to the resilience of matter, the power of gravity, and the boundless creativity of the cosmos. They should not exist. And yet here they are, defiant, beautiful, terrifying, and waiting. Chapter 8. The universe is watching. For centuries, humanity has looked up at the night sky and found solace in the apparent emptiness, imagining that the universe was a vast and indifferent expanse, stretching far beyond the reach of our senses. We told ourselves that we were alone, isolated, cradled in the quiet of a tiny blue planet. But as our eyes and instruments have grown sharper, as our reach has expanded into the dark, it has become increasingly difficult to believe that emptiness is the whole story. The cosmos is vast, yes, but vastness does not preclude presence. Somewhere in the silence, there may be awareness. Somewhere among the swirling galaxies, the dense clusters of stars, the drifting clouds of dust and gas, there may be eyes looking back. Our search for signals from the cosmos has always been a delicate, almost timid endeavor. Radio telescopes sweep across the heavens, listening for a whisper, a pulse, a pattern that stands out against the cosmic static. For decades, we have trained our instruments on nearby stars, distant pulsars, and the edges of the observable universe. Occasionally, we detect something unusual, a fleeting signal, an anomalous burst, a flicker that refuses easy explanation. Most are dismissed as noise, the byproducts of distant stars or cosmic interference. Yet some defy categorization entirely. They arrive as if someone or something was deliberately sending them, and then they vanish, leaving only the memory of a pattern too precise, too structured, to be natural. Consider the mysterious fast radio bursts, or FRBs, first discovered in 2007. These intense, millisecond-long pulses of radio waves travel across billions of light-years, arriving at Earth with energies that defy simple explanation. Some repeat, others do not. Their origins remain uncertain, and yet their existence challenges the notion of a silent universe. When we study them, we are faced with a disquieting thought. The cosmos is not simply empty space punctuated by stars. It is a theater of forces and phenomena, some we understand, many we do not, and perhaps some that are conscious of our gaze. Beyond the signals, there are the patterns of the universe itself. The cosmic microwave background, the faint afterglow of the Big Bang, is not uniform. Its subtle irregularities, the ripples in the fabric of space-time, contain a record of the universe's earliest moments. Some scientists have even suggested that these fluctuations could carry information encoded across the vast stretches of time and space. Could the cosmos itself, in its infancy, have left messages for those who would come later? Could the universe be structured in ways that allow it to observe, to respond, to interact with the life that eventually arises within it? These are questions that push the limits of science and philosophy, blurring the line between observation and participation. There is a certain existential unease in imagining that the universe is watching. Our notions of privacy, of being hidden in the dark, evaporate when we confront the possibility that even in the empty stretches between galaxies, there might be perception. We think of ourselves as minuscule, but the act of observing, of reaching out with our instruments, might be registering across dimensions we cannot yet perceive. Perhaps our signals, whether intentional or inadvertent, are the equivalent of a whisper carried across a vast hall, reaching the attention of something far greater than ourselves. The idea is not entirely alien to physics. Quantum mechanics suggests that observation is not passive. The very act of measuring, of interacting with a particle, changes its state. In a universe governed by laws that seem indifferent, the principle of observation introduces a subtle feedback loop. To look is to affect, to be seen is to participate. Could this principle scale up? Could consciousness, or awareness, exist on cosmic scales, where entire stars, black holes, or clusters of galaxies might, in some unfathomable sense, register our presence? These are ideas on the edge of speculation, yet they resonate with patterns we observe in nature, from the microscopic to the astronomical. Even our own planet may betray our existence in ways we scarcely understand. The light we cast into the void, the radio waves, the reflections off the moon, and the subtle heat signature of our civilization are detectable across interstellar distances. Civilizations on distant worlds, if they exist, and if they have the means to observe, might already know we are here. The thought is both humbling and terrifying. We are not the passive observers we imagine ourselves to be. In reaching outward, we may already be reaching inward, into the awareness of something vast and inscrutable. History offers whispers of a universe that watches, though we have often dismissed them as myth. Ancient civilizations spoke of beings in the sky, of gods whose eyes penetrated the heavens. Perhaps these stories are echoes of a deep, intuitive understanding that the cosmos is not merely a stage, but a participant. That life and observation are entwined in a cosmic dance, stretching across eons and light years. Whether these tales reflect literal truth or metaphor, they resonate with the growing evidence that the universe is far from indifferent. Recent discoveries in astrobiology suggest that life, once thought to be a rarity, may be a natural consequence of cosmic chemistry. Organic molecules exist in interstellar clouds, complex compounds forming in the cold darkness between stars. Exoplanets are abundant, some residing in habitable zones, their conditions conducive to the emergence of life. It is increasingly difficult to imagine a universe in which life is a singular event, confined to Earth. And if life is widespread, consciousness may be as well. Somewhere out there, across unimaginable distances, other beings may be observing, thinking, perhaps even contemplating us in return. Mathematics itself hints at this possibility. The laws of physics are universal, consistent across space and time, suggesting that any civilization capable of perceiving these laws could reconstruct much of the universe as we know it. They might recognize our signals, our patterns, our planetary movements. They might understand us without ever needing to come near. In this sense, the universe becomes a mirror. The more we learn, the more we reveal ourselves. Each discovery, each observation, is a message sent and received, a dialogue that transcends distance and time. Yet the notion of a watching universe does not demand intelligence or intention in the human sense. Even the simplest forms of cosmic interaction, gravity waves rippling through space-time, the collision of neutron stars, the slow pulse of a dying quasar, can be understood as forms of cosmic awareness in a purely physical sense. The universe records every event, from the tiniest particle collision to the most cataclysmic explosion. In this record, nothing is lost. Perhaps we are both observers and observed, participants in a grand ledger that spans all existence. There is an emotional resonance to this realization. It is at once terrifying and comforting to know that the universe may watch, that it may respond, that our presence might echo across the stars, challenges our assumptions about isolation and loneliness. It suggests that our lives, our struggles, our triumphs, are not confined to Earth. They are part of a narrative that unfolds on a scale far greater than we can imagine, written in the language of physics, mathematics, and perhaps consciousness itself. Some scientists caution against anthropomorphizing the cosmos. They warn that we risk imposing human traits, awareness, intention, purpose, onto processes that are indifferent. And yet, even within strict scientific reasoning, there is room for wonder. The universe responds to our probes, to our measurements, to our questions. Every observation alters the system we study, from quantum experiments to planetary mapping. Observation is not passive. Participation is unavoidable. If this principle extends beyond our instruments, beyond our understanding, then perhaps the cosmos itself participates in the dance of existence, watching as life arises, evolves, and reaches out toward the stars. In considering the possibility that we are watched, we confront the profound interconnectedness of existence. Stars form and die, planets orbit and drift, and life emerges in countless forms. Each process is a ripple, a signal, a trace of consciousness or at least of interaction. Our own act of observing, of searching for meaning in the void, might be the universe recognizing itself, a reflection of cosmic self-awareness. In a sense, we become both observers and the observed, a bridge between the silent past and the unknowable future. The universe is vast, indifferent in some ways, but not necessarily empty. Its silence may be a language we have yet to understand, a dialogue conducted across dimensions we cannot yet perceive. To imagine it watching is not mere paranoia. It is humility, an acknowledgement of our place in a cosmos that is far stranger and more intricate than our senses can fully grasp. We are small, yes, but in our smallness lies a unique capability. The ability to look up, to listen, to wonder, and perhaps to be noticed in return. And so we continue, telescopes scanning, signals recorded, theories formulated, our consciousness stretching outward like a beam of light across the void. Whether the universe is aware of us, whether it responds, whether it watches with something akin to understanding, we cannot say. But the very act of asking, of reaching, of imagining, transforms the emptiness into something alive, something profound. The cosmos is not simply a backdrop. It is a participant in the unfolding drama of life, a witness to the fleeting, fragile spark that is humanity. In the vastness of space, we are never truly alone. Somewhere, in the quiet darkness beyond the stars, the universe may indeed be watching. Chapter 9. The Fragile Blue. From a distance of hundreds of millions of kilometers, our planet appears almost impossibly small. A pale blue, suspended in the vast, dark expanse, drifting silently among the stars. It is fragile, delicate, and, against all odds, alive. This tiny sphere, hardly noticeable from the cosmic stage, is home to every story ever told, every dream ever imagined, every life ever lived. And yet, in the scale of the universe, it is nearly insignificant, a mere speck adrift in a sea of infinite possibility. Despite its size, Earth is extraordinary. It is a haven of water, of air, of light. Its magnetic field shields it from the unrelenting bombardment of solar wind, while its atmosphere bends sunlight into the endless spectrum of color we perceive each day. Life here emerged from chaos, simple molecules arranging themselves into complex patterns, enduring floods, ice ages, and cataclysms until the tapestry of living beings stretched across the continents. Each ecosystem, each creature, each grain of soil represents a miracle against the backdrop of a universe that cares little for existence. But the fragility of our home is not only poetic, it is mathematical. The universe is violent, and the violence is constant. Asteroids and comets, wandering remnants of cosmic formation, sweep through the solar system, remnants of creation capable of annihilation. Each orbit is a gamble, each collision a possibility that could erase life without warning. In the geological record, Earth bears the scars of these near misses, of the asteroid that ended the age of the dinosaurs, of the icy catastrophes that reshaped oceans and continents. Humanity exists in the aftermath of a cosmic lottery, inheritors of a rare and fleeting stability. Earth's stability is delicate not only in the face of celestial hazards, but also against the inexorable forces of the universe itself. The sun, our steadfast companion, has been burning for 4.6 billion years, yet it is slowly changing, its core swelling and simmering, imperceptibly altering the climate that makes life possible. The oceans, the atmosphere, the very composition of Earth's crust are balanced on a knife edge. A shift too great in any direction, too much heat, too little water, too much carbon, could transform our home from a cradle of life into a barren desert. And yet, humanity has only recently begun to grasp this vulnerability. For millennia, the cosmos was a backdrop, a silent stage upon which human history unfolded. Only in the last century have we looked outward with tools that reveal the enormity of the universe, the violence that pervades it, and the precariousness of our existence. Satellites orbit overhead, mapping asteroids that might threaten us, telescopes peer deep into the sky, detecting distant supernovae that could one day bathe Earth in deadly radiation. We study climate change and tectonic instability, and slowly we come to understand how fragile this balance truly is. The fragility of Earth is mirrored in its rarity. In the universe we observe, planets are everywhere, but few resemble our own. Some are scorched gas giants, trapped in eternal heat, their clouds seething with acids. Others are frozen ice worlds, their surfaces unyielding and dead. And yet, here is Earth, a liquid planet, warm enough to sustain water, resilient enough to endure cataclysm, yet gentle enough to allow life to flourish. In a cosmos governed by chance and physics, the conditions that support life as we know it are astonishingly rare. Even more astonishing is the complexity of life itself. Every organism, from the tiniest microbe to the largest whale, exists because countless conditions aligned perfectly. Each species is a product of adaptation, of survival through uncountable generations, each mutation a roll of a cosmic die. The ecosystems we rely upon, forests, oceans, wetlands, are intricate networks, each species a thread in a web that sustains the whole. Remove one, and the balance can shift. Remove many, and collapse follows swiftly. Humanity, the latest actor on this stage, carries unprecedented responsibility. Our intelligence and technology have allowed us to rise above mere survival, to manipulate our environment, to probe the depths of the universe, to contemplate the fragility of our own home. But with this power comes danger. Pollution, deforestation, climate change, nuclear arsenals, all are marks of our ability to alter the planet, sometimes irreversibly. Our species has the potential to protect Earth, or to imperil it. Unlike the asteroid that struck eons ago, our destruction would be self-inflicted, born not of chance, but of choice. And yet, in the face of these dangers, Earth continues. Storms rage, oceans swell and recede, life adapts, endures, and persists. Forests regrow after fires, corals rebuild after bleaching events, and species evolve to meet new challenges. The resilience of nature is profound, but not infinite. Humanity stands at a crossroads, to honor the rare gift of life on this pale blue, or to squander it. From space, the boundaries of nations, the constructs of human society, vanish. Earth is whole. No borders mark its oceans, no walls divide its skies. From this vantage, the fragility of our existence becomes evident not only in physical terms, but in moral ones. We are bound together by circumstance, by shared vulnerability, by the necessity of preserving the only home we have ever known. The universe does not recognize our divisions. Stars, black holes, comets, they care not for our wars, our politics, or our prejudices. Against the vast indifference of space, humanity must either collaborate or perish. Yet hope resists. From every corner of the globe, scientists, dreamers, and ordinary people act to understand, protect, and sustain this planet. Renewable energy rises, conservation efforts spread, and awareness of our shared responsibility grows. Humanity is fragile too, yet capable of extraordinary feats. Just as life emerged against unimaginable odds, we have the power to preserve it, to safeguard the fragile balance that allows us to exist. And there is perspective to be found in the cosmic scale. From the distance of another planet, Earth might appear insignificant, a pale, in a vast, dark void. Yet for those who live on it, it is everything. Every discovery, every work of art, every act of love, every life lived in wonder or struggle occurs here. The entire story of civilization is confined to this speck. To protect it is to preserve not only life itself, but the entirety of human meaning and achievement. In the cosmic theater, we are brief and fragile actors. But in this brevity, there is beauty. We live on a world that is resilient yet delicate, violent yet nurturing, small yet infinite in its significance to us. The pale blue that holds the sum of all that we are, all that we were, all that we might become. And in its fragility lies a profound truth. Life is rare, Existence is precious, and our home is worth defending with every measure of our intelligence, compassion, and courage. As we gaze toward the stars, contemplating distant galaxies and black holes, we must remember the fragile blue. For it is here, suspended in the darkness, that the extraordinary miracle of life occurs. It is here, on this small and improbable planet, that we dream, that we hope, that we strive to understand the cosmos even as we remain at its mercy. Earth is not merely a backdrop to the universe. It is the rare, precious, living heart within it. In the end, the universe may remain vast, indifferent, and often violent. But here, on this fragile blue, life persists. And in our awareness of its fragility, we find not despair, but purpose. The stars may stretch endlessly, the galaxies may swirl in silent grandeur, but our home, small and luminous, demands our attention, our care, and our awe. To look at Earth from the void is to see not just a planet, but a miracle, an island of life in the vast cosmic ocean, worthy of every effort to protect and cherish. We are the stewards of this pale blue. In the face of a universe that does not bend for us, that does not care, our choices carry weight. Every effort to preserve, every action to restore, every commitment to sustain life is a defiance of cosmic indifference. And in that defiance, we affirm not only the value of our planet, but the meaning of existence itself. Earth is fragile. Earth is rare. Earth is home. And in the endless darkness of the universe, that may be the most extraordinary thing of all. Chapter 10: The Question We Can't Escape. For as long as we have lifted our eyes to the sky, a single question has whispered in the quiet of our curiosity. Are we alone? It is a question that begins simply, almost childlike, yet it grows heavier with every discovery, every probe sent into the void, every radio signal that hums through the darkness, unanswered. The question persists because the universe, in its unimaginable vastness, suggests that the probability of solitude is unlikely. Consider the scale. There are more stars in the observable universe than there are grains of sand on every beach of Earth. Around many of these stars circle planets, some rocky, some gas-laden, some perhaps as alien to our understanding as a thought is alien to a tree. In the last few decades, we have learned to detect these distant worlds, to measure their atmospheres, to glimpse their surfaces in the faintest glimmer of reflected light. And yet, despite the numbers, despite the probability, we have seen no indisputable evidence of life beyond Earth. No clear communication. No unmistakable signs of intelligence. Just silence. But silence is a relative term in a cosmos this immense. Perhaps we are not yet listening with the right ears. Perhaps we do not yet understand the language in which other civilizations, if they exist, might speak. Perhaps the very nature of life elsewhere is so different that it passes unnoticed, invisible to the instruments we rely upon. Life may thrive in ways that defy our biology, in forms that cannot breathe our air, drink our water, or dream as we do. We may be staring at it and not even recognize it. And yet, the human mind cannot rest. The question of extraterrestrial life is a mirror, reflecting our own fears, our own hopes, and the essence of what it means to exist. To imagine life elsewhere is to imagine our own fragility and our potential for greatness. If we are not alone, what does that mean for the story of Earth, for the fragile history written on our blue? Are we the rare exception, a spark in a dark forest, or a common thread in the grand weave of the cosmos? In the silence, we imagine. We imagine intelligence across the stars, civilizations older than our sun, civilizations that may have learned to harness energy on scales we cannot yet comprehend, civilizations that might have witnessed the birth and death of galaxies. If they exist, they are not bound by the same fleeting sense of time that governs us. They may have already asked the same questions we ask now, and perhaps they have solved them. Or perhaps they, too, dwell in an eternal uncertainty. Yet, the possibility of contact carries with it profound implications. To encounter another civilization would be to confront the limits of our understanding. Would they be benevolent, curious, and eager to share? or indifferent, viewing us as a mere curiosity, or perhaps a threat. History has shown that encounters between civilizations of vastly differing technology rarely end without conflict. Could the universe hold a reflection of our own human failings? Or might it offer a vision of what we could become, of what humanity might one day aspire to, unbound by our petty conflicts, our fears of the other? The search itself has become a testament to our species' resilience and audacity. Projects like SETI scan the skies, listening for whispers of radio waves, flashes of light that might carry meaning. Space probes venture into the outer reaches of our solar system, carrying messages on golden records, messages meant for whoever, or whatever, might one day find them. We have sent our own hopes into the void, signals that will outlast generations, drifting past planets and stars that will never return them. And yet, every unanswered echo brings both frustration and a strange sense of awe. Perhaps the question is not merely whether we are alone, but whether we are capable of understanding what it means if we are not. What would happen if one day a signal arrived, clear and unmistakable, a pattern designed to be recognized, a message from beyond our small sun? How would humanity respond? Would we unite in the recognition of our shared place in the cosmos, or fracture under the weight of fear and uncertainty? Could we comprehend their technology, their biology, their philosophy, or would it seem as magical to us as our own technology would seem to an ant? Even in the absence of contact, the question shapes us. It drives exploration, it drives science, it drives philosophy. It forces us to look at ourselves as a species, to question our ethics, our stewardship of Earth, our readiness to step into the wider universe. Are we prepared to meet a civilization whose history is measured not in centuries, but in millennia? Are we ready to learn from the cosmos, or merely to project our own narratives onto it? Some scientists argue that perhaps contact is inevitable. With the right combination of time, technology, and luck, our species may one day reach the stars, carrying our curiosity, our fears, and our imperfections with us. We may discover worlds that host life in its myriad forms, worlds that challenge everything we think we know. And in those discoveries, we will confront ourselves, forced to reckon with the implications of not being the only consciousness in the universe. Yet there is also the humbling possibility that we are rare, unique even, that life, and intelligent life, may be vanishingly scarce, a miracle of chemistry and circumstance. If so, then the question takes on a weight of responsibility. Every choice we make, every path we take, every planet we touch or disturb, becomes part of a story that may never be mirrored elsewhere. To preserve life on Earth is not merely to safeguard our species, it may be to preserve a singular manifestation of the universe's potential. And in that tension, between hope and fear, between probability and solitude, the question persists. It cannot be answered by mathematics alone, nor by telescopes, nor by theory. It is existential, philosophical, and profoundly personal. It is a question we ask in the stillness of night, in the quiet moments when the enormity of the sky reminds us of how small we are, and yet, how extraordinary. We continue to reach outward, to search the heavens, to listen for the faintest trace of understanding beyond ourselves. Perhaps the universe is silent, but perhaps it is also patient, waiting for us to grow, to mature, to earn the privilege of recognition. The question itself is a bridge, connecting us to the unknown, connecting our consciousness to a reality that stretches far beyond the boundaries of our perception. In the end, the universe does not demand answers. It demands courage, the courage to look, to wonder, to question, and to imagine. To imagine life beyond Earth is to imagine a story far greater than our own, a narrative in which we are both participants and observers, actors on a stage far vaster than the world we know. It reminds us that our search is as much about understanding ourselves as it is about understanding the cosmos. And so we ask the question, and we keep asking it because it is not merely a question of science, but of identity, of legacy, and of hope. Are we alone? Perhaps. Or perhaps, somewhere in the infinite expanse, the answer waits, not as a revelation, but as an invitation to grow, to explore, to reach, and to imagine a future in which the silence of the stars is not empty, but filled with the promise of connection, understanding, and discovery. In every whisper of cosmic wind, in every flicker of distant light, we feel the presence of the unknown, the possibility of something more. And though we do not yet know the answer, the pursuit itself shapes our story, transforms our perspective, and elevates the human spirit. It is a question without an ending, a journey without a final destination, yet it is the most profoundly human journey we can undertake. Because in the vast theater of the universe, in its silence, its chaos, and its infinite possibility, there is one truth we cannot escape. The question is not simply whether life exists elsewhere, but whether we are ready to meet it, to learn from it, and to become the species we were always meant to be, curious, humble, and infinite in our imagination.